Hello. So as mentioned, today we will discuss about the numeric data type. And numeric data type is very important. Why? Because suppose you are writing a program. Suppose you are writing a program and your outcome is kind of the numeric. You are writing a program and your outcome is kind a numeric outcome. So no matter whatever your output, just you need a numeric indicator. You can change the numeric indicator value to speed, name to the speed. Okay. You can change your numeric indicator as a pressure. You can change your numeric indicator name as a temperature sensor, because LabVIEW provides you the facility where you can easily rename your object based on your requirement. Okay. Now, I think all of you are very much aware about the numeric controls. In this numeric control, suppose here I have one numeric control A and another numeric control B. Now I want to just write a subtract function program. So for that you need to right click. You have to come to the numeric, take a subtract function, place here. Then right click on the functions. When you will right click, you will get a shortcut menu. Click on the shortcut menu. You will get visible item. You will get visible item. Label. Open the label. Make a connection like this. So whenever you will take a control on the control palette, automatically a control indicator will appear on the block diagram. Respectively, it will follow the data types. If you take a numeric indicator, so it will be display a numeric indicator terminal. If you will take a numeric control, so it will be make a numeric indicator, sorry, numeric control terminal. If you will take a string control, so it will be display you a string control terminal. So now there is terminal node. Click this terminal node to this click terminal node. Then we don't have any idea what kind of indicator we have to choose. So for that, in the functions node, right click. When you will right click on the particular node, you will get here the create indicator option. Click on the create indicator. It will be display a proper indicator for your functions. Later you can rename it. Like here, I want to rename A minus B. Every time, okay, now run the program and you can check. Many times you no need to create control from the front panel. Suppose we have one functions, multiply functions. When you will right click on the block diagram, you will get a function palette. In the first column, first row, second row, you will get numeric. On the numeric, you will get a multiply. If you will take this multiply and you will place here, and after that, when you will right click and create indicator, so it will open your, sorry, right click, open the label. After that, if you don't know what kind of input this particular function will accept, so for that, you can do this practice. First of all, you have to right click on the particular node and you have to click create control. Again, you have to create control. Using this way, you can create the control for your particular function. And we know very well, using the controls, we can give the input. Now create indicator. If you are finding your program is scattered, if you are finding your program is scattered and you are not able to manage the program, so at that time you can place control A. By pressing control A, you can select all function, then you can press control U. By control U, using control U, you can arrange your block diagrams element. So for that, first press control A, then control U. That is not possible in LabVIEW 2021. Okay, and it is I am doing using my that screen recorder. That function has been added in 2023 only. After you can click and if you want, so you can click here and you can sorry, I am using my touchpad. I am using my touchpad. If you want, so you can also try it. Let's see. Yeah, are you able to see control place control plus control plus plus. Please try control plus plus and control minus control plus minus. Hello. If possible, then are you able to see the larger control plus plus sign or control plus minus sign? They had introduced this facility, zoom facility, by the cursor moving. Okay, earlier many times we try, I don't know, but okay, in your computer I think you will not get this also. Here, execution highlight medium, are you getting the execution highlight medium? Great. Okay, highlight execution medium, their medium. Okay. Now, if you will right click, you will get here in your condition NXG. But I am getting the fuse design system. In your system, you are getting the control here, create function above this. Above the visual item, you are getting the control. Create control, create indicator, create constant, right? Yeah. Now, if you are able to increase the block diagram, so that's great. Now, control A, control U. Now, it is a way you can write the program. But here I want to tell you one thing. During the programming, always follow the A minus B. Always remember A minus B is not equal to B minus A. Like A plus B is equal to B plus A, and A multiply B, okay, is not equal to, like, A multiply by B is equal to B multiply, sorry, B multiply with A. But it will may not follow when you will write a program for divide. A divided by B is not equal to B divided by A. So during the programming, you have to think about it. Now, come here. Let's save this program. Save as. Go to your location. As I had created a location. Okay. Day 4. Day 4. Okay. Now let's go to the next session. Next, sorry, step. Open your UI. Suppose we have to write. Suppose we have to write a program for average of two numbers. So for that, we can take numeric control A and numeric control B. Numeric control B, A and B. After that, you can add the both A and B. We know very well the average is addition of two numbers. Average, the formula of average is addition of all number divided by the count of the no, elements. Addition of all element divided by the count of element. So here, suppose we are try to write a program for average for two number. So A plus B, then you can take a divide function. Now we know very well here A and B user can change as per their requirement. So always A plus B will be the user dependent. But this divide by 2 will be the system. Okay, it will be a fixed value. So whenever you want to give a fixed value, we need a constant, and you can avail the constant from the numeric function palette. So here in the numeric function palette, you can see the dbl numeric constant, dbl numeric constant. So you can take this dbl numeric constant and you can place here. Now you can place constant value 2. Then right click, create indicator, average. of two numbers, average of two numbers, right? Very easy. And this program will work. We'll use this function in our future. We'll use this function. We use this function as a program. We can use this function. Sorry, we can use this program as a function in the future when we'll work as a program subroutine. At that time, we will try to call this program as a function. So now you can check and you can save this program. Average of two number. It is a constant. If you have done the program, so please let me know. We will go to the next. Okay. Now open a new VI, press Ctrl T. I want a function here. Right click, come into the numeric, and in this numeric, there is a function, and this function is a random number generator. Many times we need this kind of the function, random number generator. Suppose you want to write a program for the Ludo, okay, and you want to control the dice of the Ludo, so you need a random number generator which can generate number between 0 to 5, means 0, 1, 2, 3, 4, 5. These are 6 numbers, and based on the 0 to 5 or based on 1 to 5, 6, you can control your dice, but it should be a random each and every time. Are you getting my point? So at that time we need a random number generator as a number generator or controller for a dice. So a random number generator, from where you will get this random number generator from this function, from numeric function palette, fourth column, fourth number or fifth number, fourth column, fifth number, right? Now press Ctrl H. Whenever you will press Ctrl H, you will get context help. Now in this context help, you can read a random number generator can produce a double precision floating point number between 0 to 1. Number will be greater than or equal to 0 but always less than 1. So now right click, create a indicator. Now you can see here, run. Whenever you will run, every time it will generate a new number and it will not repeat. It will not repeat itself. Now sir, ma'am, the task is we are able to generate number between 0 to 1 only. I want to generate the number. I want to change the range of this number. I want to change the range of this number. I want to generate the number between 0 to 10 or 0 to 100 or 0 to 25. So what can I do? Change the upper limit. There is any possibility to change the upper limit? Let's come into the property. There is not possible to change the upper limit. The second option is multiply. Let's take a multiplier. Take a multiplier, put here. Right click, create a control and put change the name range. Range. Okay, range. Right click, create indicator. RAN random number with range. Okay. Now, whatever the value you will put inside the range, this program will extend your number till that range. Suppose if I will put it 100, so I will get the random number between 0 to 100. Now, if one customer will come and he will say, sir, I need a, sorry, not the customer. Suppose to control to control our dice for Ludo game, we need only absolute value. We need only the integer value. Okay, we don't need the decimal value. Absolute value we know. Then we need to find out the way, and the way is here. Round to nearest. You can take the value round to nearest. Okay. Now it will give me the value only the integer number. But there is a very beautiful thing which I am going to show you about the round to nearest. Right click, come here, take a round to nearest. Create indicator for this round to nearest function. It is a separate and different function. In LabVIEW, you can run two different functions. In LabVIEW, you can run two different functions in the same platform, and both will be work independently. There will be no data dependency required. Okay, no parallel, no serial communication. Both program will be run independently. Now create indicator. Round to nearest. Create indicator. Sorry, create control. Hello sir, look at here. Now tell me what value if I will give here 4.3.5. So output will be 4. If I will give the 4, just a second. Here, let's increase it the front size or size 24. Okay. Now, suppose I am giving the value 3.5. So it's give the value 4. If I will give the 5.5, so it will give the value 6. Okay. Suppose I will give the value 7.5, so it will give the value 8. If I will give it the 5.5, then 6, and 4.5, okay, 5.5, then again 6, 5.5, 6, and 6.5. Can you tell me, sir, what value will get? We'll get the 6. For the 6.5, we'll get the 6. 8.5, we'll get the 8. Always your round to nearest function will select nearest impossible nearest even integer. Nearest even integer. Okay. Save this program. Please try if you have done. Done, we'll go ahead. I'm sorry. Please try. When you will done, inform me. Now take a new VI. Sir, if you're not liking this platform, block diagram or front panel, okay. Suppose you're not liking this front panel, this color, and you want to change something. You want to change this background. So you can right click on this scroller. Are you able to see this scroller? Are you able to follow my cursor? Right click and come into the properties. Okay, background, browse option, go anywhere. Like I'm going to the desktop. If there is any image, NI. Okay, so I will get the NI image. If you want to scratch, so you will get one NI. You want to fix it center, so center NI. Either you want to fix it. Okay, and it will not affect your program. You can change the entire background. You can put your image also. Now, come into the numeric. There is a one function, and this function is there is a one function. This function name is quotient and remainder. There is one function compound arithmetic. If you want to add more than if you want to add more than two numbers, or you want to subtract more than two numbers, you want to multiply more than two numbers, so you can use in compound arithmetic. I'm going to show you. We have a, okay, copy and paste, copy and paste, ABC. Now right click, come here, take a compound arithmetic. Now you can see in this compound arithmetic, you will get by default two input only. In this compound arithmetic, you will get two input only here in the left side. Okay, and in the right side, okay, I didn't explain about the cursor behaviors sorry, using this example, we'll discuss. Okay. Now, please look at here. I think my cursor is visible to all of you. Right now, what is the cursor type? Please tell me what is the cursor type?
Plus sign.
Plus sign. That means it is just a operating tool. What is operating tool? When I will touch any node, so it will be convert as a dumbbell shape. Now it is a connecting tool. Okay. After changing this dumbbell shape, you can connect your functions, objects. When you will touch any object, when you will touch any object or any functions, any object or any functions, okay, when you will touch any object or any function, so it will become a arrow. When it will become arrow, so then you can click and you can move. So it is positioning tool. It is a positioning tool.
Hmm.
Whenever your cursor will appear like this, like now you can see here, look at here, behavior, look at here, just it is a my plus sign. Here automatically it's converted as a dumbbell shape as a connecting tools. Now automatically it's convert, it's changed as a expansion for expansions. Okay, you can expand the number of it. Now look at here, when it will be change, when it will become a arrow, so you can change the positioning tool. When it will become this fingertip, that means selection. Now you can select the option. Okay, so by clicking here you can select the option and you can change the add, multiply, and or and XOR. And by expansion you can add extra input for the particular function. When you will done, inform me, sir. I hope now you have done this program. Save as. No matters. Now here I'm going to explain a very important concept about the numeric data type in LabVIEW. When you will right click and you will come here, so you will find this blue color numeric. You will get this orange numeric. Let's take a blue color numeric, numeric control and numeric indicator. Make a connection. Just try to copy and paste. Okay, sir. Now look at here. When you will right click and you will come into the representation, means this numeric control. Okay, using this numeric control, which kind of numeric data we can write. So now the numeric control is DBL type of numeric control. DBL type of numeric control. That means it has a double precision floating point, and it has a 2 to the power 64 bit memory. It is allocated with a 2 to the power 64 bit memory. Okay, the memory has allocated for the 2 to the power 64 bit. Using this a representation, you can write any number. You can write any number in between plus and minus. Positive and negative. You can write any numbers with the positive and negative along with the decimal. Now right click, come here, come to the properties, come to the properties, and in this property, here you will get data format. Sorry, data types. Let's see here. Okay, data types. It is a double precision data types. Double precision data types. When you will press Ctrl H and you will touch any functions, so you will get to know it is a double precision data type. You can write any real numbers, any positive and negative numbers with a decimal. Okay, the color orange color show you can write any decimal value, any floating value, any real value, any numbers with the decimal. But there is one representation change. When you will come here, you will find I64, I32, I16, I8. Let's take I8 because it is easy, okay, to explain. I8. Now you can see when I will change it I8, so color has been changed. Let's try to write minus 12. It is sign bit integer using I8 is equal means 2 to the power 8. That means you can write 256 number because it is I8, so you can write number from minus 128 to plus 127, in between plus 127. Using I8, you can write minus 128 to plus 127. Okay, let's try to write minus 128. Sorry, minus 128. Is it possible? So yes, we can write it. Can it will go less than minus 127? Let's try to decrease it. It will not generate less than minus 127. So sorry, 128. And it will not generate value greater than 128. 27. Now you can see it is an integer value. It will show you the only integer value. You cannot write any kind of the decimal value here. It will help you to write any integer value between minus 128 to 127, just because the memory allocated memory is 8-bit. Still my indicator still my indicator is associated with the floating parameters, dbl, okay, representation. That's why the capability of this indicator is to display any numbers. It can display any number, but when we know the producer has the limitation, the producer no, producer the producer has a limitations to the date number between minus 28 to plus 27, and we are taking a consumer with the okay, floating representation. So here you can see one red dot is coming. This red dot is conversion. It is a auto conversion. Okay, it's a auto conversion. It will convert our 8-bit to the 64-bit. Forcefully, it's converting our 8-bit value to the 64-bit, which is not required right now. Our producer has capability for 8-bit, but our consumer has a capability to accept 64-bit data. We know if we will make a consumer with 8-bit, I8-bit, so we can easily display the producer's entire number. Here we are wasting the memory, and it's create a corrosion. It's create a corrosion because you are using unwanted extra memory. Getting my point, sir? So it is a my numeric indicator, okay, controls. So we need to change numeric indicator with the same. Now the corrosion block has been disappear. Now the memory size for the both number will be the same. Suppose here I am taking a number, I am changing the representation I8, which is as same, and here if I will convert the representation to the U8. So what is the U8? U8 has the same concern, 2 to the power 8 bit, 2 to the power 8. Okay, it can write 256 value, but here the range has been changed. It will display number from 0 to 255. 0 to 255. Now let's examine. If here I will write minus 1, so it will display you my okay 255 for 00112233, and I know it cannot write more than 127, so automatically it's changing it 127. If I will write 400, so it is okay, it's checking the maximum number, but it has the capability to display number from more than 127. It can display the value till 255, 0 to 255, but it okay, but this function has capability to register negative number, but this function don't have capability to display that negative value. Are you getting, sir? Now, okay, so it is an integer, unsigned integer. It is a signed it is signed integer, and it is unsigned integer. U8 unsigned. U means unsigned. So we have two kind of the numeric here. Numeric functions and controls. One is the DBL, where you can write any number with any means positive, negative, decimals. And here you can write only integer, but there is also certain limitations. Either you can go with the unsigned assigned integer, where you can write positive, negative, or unsigned integer only 0 to positive value. Now you can see we are our generator, our producer, number producer has a capability for minus to okay, mm, minus and for the positive and negative. Now both have the same memory, 2 to the power 8-bit memory, but here the okay memory and allocated memory is 256 for both, but the behavior is the same. Now you can see the behavior of this 8-bit number is positive, okay, unsigned, sorry, signed. That means it can generate and it can generate and display positive and negative number, but it can only display the number from 0 to 255. Again we are getting the red dot, means corrosion dot. Now we are forcefully try to, now the program is forcefully try to convert your this number I number to the U number. So if you will say, sir, what is the problem? We are not facing any problem, then our program is correct. If suppose it is a DBL, so easily you can write all the numbers, and you will say, sir, our program is working, so we are happy with the program, right? Yes, you are happy with the program because you are doing just a normal programming. Suppose you are working on the FPGA, or you are working on the ECU test, you are working on ECU development phase. There you have to manage the memory. Every time you have to manage the memory. You know your number will not go more than 200. 0 to 200 will be the maximum number, or minus 100 to plus 100 is the maximum number. Your system will work with the minus 100 to plus 100. At that time, ethically you have to choose this one. Just a okay, just a coder with just a coding mindset or just a programming mindset. If you will come, so you can select this one numeric, but with a proper okay professional behavior, with a proper professional mindset and programmable mindset, you will come as a proper development phase. So ethically you have to select this one because it will use less bit, so file will be generated with a less bit okay size. And also you can filter integer number very easily than a decimal number. You can control integer number very easily than a decimal number. If I will give you a task, please count how many decimal numbers are available after, okay? So that will be a tough task for you. Yeah, you can do, I can also do, but that will be a tough task for you. Sure, sir. Yeah, yes. To become a good programmer, to become a good, okay, programming, so to become a good programmer or to write a effective program, always try to avoid okay unnatural things. Don't use extra any line of code if you want. So at the end of the this training, when we will come out the memory management section, at that time I will show you how we can change an entire algorithm with a small program. Either if you have a time, so I can show you within okay, if you show you right now how easily we can manage the program and we can reduce the size. So these are our new numeric representation and numeric data type. In the block diagram, you will get this function. We'll discuss tomorrow this function, and other function you can use based on your requirement. Here you will get this conversion factors, all kind of functions, converters. Here you will get the complex number. You can generate the complex number if you want. So you can use this platform and you can practice more. Sorry, tomorrow we'll try to write some logic. Definitely there will use this function and this function, and also we will work on this function. We'll try to write a program where we can try to give a small memory to the function, and function will take the decision based on the outcome of our mathematical logics. We'll give the two options. Function will select one based on the best possible outcome. So thank you for today. Tomorrow we'll meet again, and we'll boost up our programming session. Please subscribe my channel, and if you want, if you want, so you can comment or you can like there.